Hello everyone and welcome to today's broadcast. Today is April 11th, 2026, and it is a beautiful Saturday. I'm your host, Sunno Annie, and I am super excited to be here with you all today. I'm introducing a trending article from the archive, and it is a really fascinating one. The title is DiV INR Extreme Low Bitrate Diffusion Video Compression with INR Conditioning. The plural is HEVC ABS 26048,329 V1. It is long. But do not let that long title scare you away, because the content is incredibly cool. So, let us dive right into the problem that this paper is trying to solve. Have you ever tried to watch a video on your phone and you have a really bad internet connection? Usually, the video becomes super blurry, or it breaks up into these ugly, chunky little blocks. That happens because of something called video compression, which is how we make giant video files small enough to send over the internet. Normally, technologies, like the ones called HEVC or VVC, do a pretty good job. But when you have to squeeze the video file down to an extremely tiny size, which experts call the extremely low bitrate regime, these troubleshooting methods completely fall apart. Specifically, we are talking about compressing videos down to less than 0.05 bits per pixel. At that tiny size, traditional video webcams just give up, leaving you with severe blurring or banding artifacts that look terrible. To fix this, some researchers started using deep learning AI, specifically something called generative diffusion models. Diffusion models are the same kind of AI that can generate beautiful images from text prompts, and they are great at creating highly detailed, realistic pictures. Applying them to video compression has been really tricky. Most current methods try to send a few heavily compressed keyframes, which are basically just standalone pictures, and then they ask the AI to guess the frames in between. The problem is this often leads the AI to make bad guesses, creating weird structures or losing track of what is happening in the video if it gets too far away from a keyframe. That is exactly where this amazing new paper comes in to save the day. The researchers propose a brand new framework called DiV INR, which combines two incredibly powerful concepts. First, they use something called Implicit Neural Representations, or INRs for short. Instead of saving a video as a series of normal pictures, an INR learns to represent the entire video as a tiny, highly compact neural network. It's like teaching a mini brain everything about the video, so the brain itself becomes the video file. Second, they use pre-trained video diffusion models. By combining these two, the INR acts as a super smart guide for the diffusion model. Instead of relying on clunky, traditional keyframes, the tiny INR network sends continuous, highly detailed heats to the diffusion model, telling it exactly how to recreate the original video. And the way they do this is just brilliant. They optimize the input weights directly within the loop of the diffusion model, meaning the two systems learn to speak perfectly to each other. They also use a clever trick to slightly adjust the big diffusion model specifically for each video, using less than 0.1% of the model parameters. When they tested this against traditional models like Blurry and even the other modern AI methods, the new approach completely blew the competition away. It preserved sharp textures, high-frequency details, and realistic movements, while the other methods just produced a blurry mess at the exact same tiny file size. They measured this using perceptual metrics, and the improvements were massive, showing up to 91% better scores in some areas. Now, let us talk about how this incredible technology could actually be applied in our everyday lives. I had thought of case-specific application examples that show just how much of an impact this could have. First, imagine video streaming in extremely remote areas, like deep in the mountains or out at sea. Right now, if you only have a super weak satellite connection or a terrible mobile signal, watching a clear video is basically impossible. But with this technology, because it can reconstruct high-definition video from almost no data at all, You could seamlessly stream your favorite movies or video call your family in crystal clear quality even if you are taped in the middle of nowhere. The second amazing application is in the world of space exploration and deep-sea research, when scientists send drones or rovers to distant planets like Mars or into the deepest trenches of the ocean. The bandwidth they have to send data back to Earth is painfully small. Currently, it takes a very long time to send back a single high-quality video clip, and it costs a lot of resources. By using this inner-conditioned diffusion compression, space agencies could transmit incredibly detailed, high-frame rate videos of alien landscapes or deep-sea creatures using the tiny bandwidth they currently have. This means scientists on Earth will get to see smooth, clear, and highly detailed footage almost instantly, drastically speeding up scientific discoveries and giving us breathtaking views of places we have never seen before. The third specific application is for massive video outshotting and cloud storage. Think about huge movie studios, security camera networks, or even normal people with thousands of videos saved on their phones. Storing all of that high-quality video takes up massive amounts of server space, which requires massive data centers that consume a lot of electricity. If companies start using this new DiV INR technology to compress their archives, they could shrink the physical size of their video databases down to a tiny fraction of what they ought to do without losing any of the beautiful visual quality. This would save millions of dollars in storage costs, and it would also be amazing for the environment, because smaller data centers mean we use significantly less energy to keep the internet running. It is just so amazing to think about how a change in the way we handle mathematics and AI can have such a huge ripple effect on our daily lives. Now, researchers even pointed out something super interesting about how the AI learns during this process. They noticed a semantic to visual hierarchy, which means the AI first focuses on getting the general layout and the identities of the objects right before it starts refining the tiny textures behind the details. It is almost like watching a human artist paint a picture where they sketch out the basic shapes first, and then spend time filling in the tiny details like the leaves on a tree or the wrinkles on a shirt. This shows that the AI is really understanding what it is looking at, rather than just blindly copying pixels. In conclusion, this paper proves that by thinking outside the box, I'm treating video compression as a way to send smart AI hints rather than actual pictures, we can achieve things that were previously thought impossible. The ability to maintain such pleasing details and high fidelity of extremely low bitrates is going to change the future of media communication and data storage. I am so excited to see when this kind of technology will be built right into our smartphones and televisions. Well, that is all the time we have for today. I really hope you enjoyed learning about this amazing new video compression framework with me. Thank you so much for tuning in. I will be back with more fun and exciting science news next time. Have a wonderful Saturday, everyone, and bye-bye.